All right, guys, this is the third and final part of chapter 11. Let's jump on in, starting with long-term infections and their effects. So we need to talk about these two terms, latency and sequelae. So latency is going to be periods of dormancy that we're going to see in some chronic infections. A great example, one that we can kind of imagine, is herpes. So this is where the infection itself, you always have it. It is always present in your system. However, the symptoms themselves will pop up intermittently. So they'll be dormant and hiding, and then suddenly there will be signs of the infection popping up later, um, possibly when your immune system is at a weaker point in time, maybe due to stress or illness. It just kind of depends. And then this term sequelae is going to be a medical term that means consequences. Now, it kind of sounds a little bit weird to call it consequences because it almost sounds like it's your fault as the patient. It's not. It's the fault of the infection itself. These are long-term or permanent damages to our tissues or our organs caused by the infection. So essentially what we're saying is we're not fully healed, it is lasting damage. For example, meningitis can result in deafness. That deafness is that consequence of having meningitis. We cannot heal it. Even when the meningitis is gone, that deafness will remain. Sometimes Lyme disease can lead to having arthritis, or polio to paralysis. That arthritis and paralysis is that end result, that sequelae of having that disease. So there are some phases or steps to having an infection. So let's look at what happens from our side of an infection, because we looked at from a microbial standpoint how to infect a host. Now let's look at it from the reverse. What happens with us as a host on the outside getting the infection itself? The first phase is going to be the incubation period. Typically, we don't know we're sick yet during this period. So this is that point in time where we come into contact with the microbe, and you can be contagious at this point in time where you show no signs or symptoms. This is an incubation period, right? So you do have the microbe in you. You are incubating the microbe. It's growing. So potentially the incubation period could be hours, it could be days, it could be months, and sometimes it could be years. It just depends on what microbe we're looking at. For example, rabies takes days before you show any symptoms, and that is the incubation period. Whereas polio takes a mere couple of hours to incubate. Phase 2 of an infection from the host side is the prodromal stage. This is a very short period of time, roughly 1 to 2 days, where you may start to feel a little bit sick, kind of maybe a vague discomfort, general malaise, muscle aches, little bit of fatigue, but you might misinterpret this period of time as just having kind of a rough day, perhaps. Maybe if you are a person who has periods, maybe you might misinterpret this as maybe my period is beginning to start and I'm just starting to feel that type of thing. It just kind of depends. Maybe you went too hard at the gym. Maybe that is what you start to think. But this is a very short period of time where you might start feeling sick. This is where the microbes are starting to accumulate. Now, this leads into phase 3, which is the acute phase. This will vary in length. This, we're officially sick. This could last days, to your whole life. It just depends on what type of microbe we're looking at. If after the acute phase, our immune system is winning, this fourth phase is going to be the important one. This is the period of convalescence, and I want you to put a star next to that word recovery. The recovery period is going to be where our microbes, not our microbes, the microbes, these pathogens, are going to still be present in our system, however, in small quantities, because our system, our immune system, is winning the fight. So we can still be contagious. You can still pass on the disease. The problem with this fourth phase, if our immune system is winning and you start to feel better, you're still contagious, and people usually stop taking their medication and start becoming more social, going back to work, going back to school, going around people. And this is how people get sick again, or how people get other people sick. So this is kind of the, the point in time of being sick that you probably still want to isolate, and always finish your medication, guys, especially if you're taking antibiotics. Very important. The fifth step is going to be the continuation phase. So either the microbe is going to linger for months or years or indefinitely after you have recovered, or the organism is going to be gone, but symptoms persist. And essentially, you're still dealing with that kind of aftermath. So this fifth phase is if that fourth phase, that recovery, isn't necessarily a full recovery. So that's if you have something like typhoid fever, where the microbe lasts in your system, or if something like syphilis or Lyme disease, you still have symptoms even after the microbe is gone. So this fifth phase, this continuation phase, is not always a must if that recovery phase is not a full recovery. So I do have this lovely graph showing the course of infection. We have the incubation period, where this time range is going to vary depending on what microbe we are infected with, and we are not showing any symptoms yet in this incubation period. Now, in the prodromal stage, we are showing a few symptoms, and remember, prodromal stage is going to be a relatively short period of time, roughly 1 to 2 days thereabouts. In the acute phase, we are going to reach the height of the infection, and this can last for some amount of time. It just kind of depends on what the infection is, where we then enter into the convalescent or recovery period. And depending on what the infection is, this could be a good thing or a bad thing. It could lead to death. It could lead to a full recovery where we are not seeing any symptoms, or the convalescent period could lead into a continuation period. It just depends. So there are kind of 3 options. If we start winning, we lead into a recovery, meaning we will not have any symptoms. Easy peasy. We love that. It could be that we're losing, and 2 things might happen. The patient could die, or you, depending on who's infected, or you go into a continuation period where we are still showing symptoms even if the microbe is gone, or if there's lasting effects of the disease. It just depends. So if I asked you the question, if you're infected with a pathogen, when are you contagious? Well, it really depends on what type of disease we're talking about. Because some diseases are able to be transferred during the incubation period, like measles. So during that time period where you're not showing any symptoms, you probably don't even know you're sick. Some only will be able to be transferred from host to host during the acute phase where you absolutely know you're sick. And some, it's through every single stage of an infection, like hepatitis B. It just depends on what disease we're talking about. So the answer to when are you contagious during an infection is we don't know. It just depends on the infection. And sometimes you don't know you're sick, because remember, some people can be asymptomatic. So if a microbe, a pathogen, is not currently inside of us making us sick, where do they exist? Where do they come from? Well, pathogens exist in something called reservoirs. These are going to be areas where a pathogen kind of resides outside of making the host ill. So some reservoirs are just humans in general. They might be individuals who are carriers that don't show symptoms. So a lot of people don't show symptoms for herpes, cold viruses, mumps, typhoid fever. We have an example of typhoid fever here in a second as far as a reservoir. So just put a pin in that for just a second. Sometimes reservoirs are animals. We call this zoonosis or zoonotic. So these are diseases that primarily occur in animals, but can jump from animals to humans. Examples include things like rabies, Lyme disease, as well as Ebola. We keep coming back to Ebola, guys. I really like that one. A third example of a reservoir is non-living areas, like the environment, like water and soil. Some examples include tetanus, botulism, and cholera. So those are typically going to be non-communal organisms, infections that don't go anywhere once they're inside of us. So that's kind of important to make a note of. Those non-living environments where those reservoirs are that have those particular microbes are usually non-communal. They will not jump from host to host, as opposed to human and animal reservoirs. Typically, those will be communal diseases that are held in those reservoirs. So there are actually 13 carrier states. These are only 5, but they are the 5 most common carrier states that I want you to know. So we have asymptomatic carriers. These are carriers that don't know they're sick because, well, they don't show symptoms of a disease. We have incubating carriers. These are individuals who are sick but don't know they're sick yet. So they are incubating, they are in that incubation period, so they aren't showing symptoms, but eventually they will. We have convalescent carriers. These are going to be individuals that are in that recovery stage, but they have enough microbes still in their system to pass on the infection to others. We have chronic carriers, which the microbe is going to hang on for long periods of time well after the recovery due to the latency of the microbe. And then we have passive carriers. And unfortunately, this one is going to be one that's a little bit closer to home for many of you. These are going to include a lot of healthcare workers. And while the healthcare workers themselves are typically not sick, it's just going to be that medical personnel have a tendency to carry microbes from patient to patient through essentially contamination, whether that's PPE or on their body in person, maybe not washing their hands under their fingernails. It just kind of depends. So it is a healthcare professional carrying maybe secretions or blood secretions, whatever type of secretions, picking up pathogens and accidentally transferring them from patient to patient. So here's a fun little example of a human reservoir for typhoid fever. Probably someone you've heard of, but maybe don't know exactly the story of. This is Typhoid Mary. She was born Mary Malone in 1869, and she was a personal cook to 8 separate families during the early 1900s. Now, unfortunately, she killed a handful of people, not on purpose. She was not a murderer. But what happened is she got typhoid when she was younger, typhoid fever, that is. And while she survived it, she ended up carrying typhoid, that Salmonella typhi, with her in her gallbladder. Now, the way that typhoid fever is passed on is through fecal oral transmission. So, what had happened is while she was cooking, she would go to the bathroom and not clean her hands and then go back to cooking, and people would eat her food. So, that was how she was causing the transmission of that particular bacteria that she was a carrier for. Now, keep in mind, she was an asymptomatic carrier of this bacteria. Now, unfortunately, it did kill people, and authorities got involved, realizing that there was some connection between these families that were experiencing these sudden deaths. And it was their personal cook. So she ended up working at another restaurant. It caused other problems. So the authorities came back to her. They were like, Mary, you have to stop. We told you you can't cook anymore. So she stopped, and then essentially she was forced to live alone in a cottage on an island until eventually she worked for a physician washing bottles and recording data for this physician. And oddly enough, she did not die from the typhoid fever. So again, she was an asymptomatic carrier of it. She ended up dying of pneumonia after a stroke many years later. But yeah, that is the story of Typhoid Mary. She was an asymptomatic carrier of typhoid fever, and she was killing people by not washing her hands when she would cook for them. So there's a couple things to take away from this story, right? So looking at animal reservoirs, we have a few examples from current history, essentially, of kind of big diseases that have popped up. COVID being from bats. SARS was from something kind of like a cat known as a civet. So HIV being from something like a monkey, I believe, jumping to humans. But essentially, the thing that unifies all of these cases is these animals were kept in close areas together, where that disease was jumping from animal to animal, as well as from animal to human. So it just so happened that these infections were able to jump from animal to human. So these are animal reservoirs, but the scary part about them is that they were able to jump back and forth between animals and humans, which is not at all a common occurrence when it comes to diseases and infections typically. So the only way to really eradicate a disease, once we have realized that we are able to contract it from animals like bats or monkeys or civets, is to essentially kill all of those animals that are infected. so that that disease essentially dies with those animals. It's not great, and a handful of times this has worked out for us. An example in the US is the mosquitoes, the species of mosquitoes that carry malaria. We eradicated those mosquitoes, and therefore in the US, we no longer have that fear of malaria. Um, but in other areas, that is kind of a sad thing to do, to completely eradicate many of that animal, because they've contracted that disease, usually mostly due to human fault. Onto that non-living reservoir. Remember, this is going to be organisms that live in soil and water, and they are pathogenic, but we are not their goal as a host. So most of these are going to be opportunistic, non-communal pathogens, because we are rarely going to be their main host. They don't really want to be inside of us. They want to stay in their soil and water. But if we do become infected, these guys can be kind of an issue because we are a dead-end host for them. All right, so let's talk a little bit more about communicable diseases and the transmission of those particular diseases. So we can have two types of transfer for communicable diseases. That is vertical transfer and horizontal transfer. Vertical transfer is going to be the transfer of a disease from parent to offspring. So moving from mother to child, usually through the milk or placenta. While horizontal transfer is going to be through direct contact from one host to another. So an infected individual to a non-infected individual is maybe a better way to say that. Indirect contact, this could be something like someone coughs on a table and then leaves, and then you go and sit down at the table and touch the table and then touch your mouth. So that is indirect contact or vector transmission. That could be something like a mosquito transmitting or transferring malaria. So let's talk a little bit more about these types of horizontal transfer a little bit closer. So with direct contact of a communicable disease, what we see is direct touching. So this is a direct touch between an infected individual and a non-infected individual from skin or mucous membranes. So this could be, if you want to think of it this way, kissing somebody or licking somebody. I don't know why you just up and lick somebody, but sure, whatever. Spitting on someone or in someone's mouth. I know, again, also don't know. I'm not going to judge you. I'm not judging the way you live your life. Or possibly through a sexually transmitted disease. It just depends. But either way, there is a direct contact, skin to skin, mucous membrane to mucous membrane, whatever it may be. Direct contact to for that communicable disease to have transmission. The indirect contact is there is some go-between. What we call that intermediate object is going to be called a fomite or vehicle. So it could be a table or a pencil or a cup. I don't know, something like that. You touch, you're infected, let's say, with, I don't know, some type of virus that can live on a surface for some period of time, like COVID could. You touch a table with your snotty, gross, coughed on hands, and then you get up and leave, and then someone else comes down to that table and puts their hands on it, and then they touch their mouth or something, or they're eating chips and they don't use hand sanitizer. Ew, gross, we hate it. Either way, the table becomes the fomite or the vehicle, because you touched the table, infected the table, and then that new person came in and touched the table after you, picking up your germs. So this is one of the biggest reasons, guys, why we spray the table every time we come into class, every time we come into lab, because we don't need that indirect contact of picking up new friends, as I like to call it, as far as little germs and bacteria go, potentially left over from the class before us. We just never know. From there, we have that third possible mode of transmission in horizontal transfer, and that is vector transmission. So this will usually come in the form of some type of insect like a flea or a mosquito, possibly a housefly. There are two types of vector transmissions: biological vector transmission and mechanical vector transmission. For biological vector transmission, this is where the vector, which is maybe a mosquito or a flea, is going to ingest the thing that causes the infection and then transmits that infection into the host. The vector itself is not going to get sick. For example, mosquitoes are going to consume infected blood that have malaria. From there, when they go to bite another host, they end up spitting into the bite, because that is what mosquitoes do. They spit an anticoagulant so that they can get all the blood into their mouths, essentially. And actually, that's what causes that itchy feeling when a mosquito bites you, is their spit. So they're spitting into you, and with their spit, they are injecting malaria. So those little protozoan parasites into your body. So the mosquito itself is not infected with malaria. It's just a vector to carry the malaria around. Kind of crazy. We are the ones that get infected with the malaria. Stupid. Hate it. Now, with mechanical vector transmission, the organism, like a housefly or something, is going to kind of house, if you will, the microbe on its body, not in its body. So maybe on the legs or wings or body of the vector, but it's not internalized. So a good example is houseflies. What do houseflies like to roll around in? And that is a poop, essentially. So there are tons of gross things, microbe-wise, that houseflies can get into by rolling around in that, like cholera or salmonella. And this is one of the biggest reasons why you should never eat something after you have visually seen a fly land on it. It is because they are mechanical vectors of transmission. So again, those microbes are living outside of the vector. When they land on your sandwich, if you're eating outside, there is a decent chance that that housefly is carrying around something you don't want to be putting in your mouth. When we talk about healthcare associated infections, or also known as nosocomial infections, this is going to be caused from a handful of factors. There are three that are pretty important, though. The first is that the areas where we see healthcare occurring are essentially collection points for pathogens, because if you're sick, where are you going to go? You're going to go to a hospital or a doctor's office. So you're taking your pathogens with you and essentially spreading them around. So these healthcare facilities are going to be major reservoirs for diseases, and also very opportunistic diseases, in fact. And this is also going to be an area where we see a lot of antibiotic resistance because these areas are going to be getting cleaned, as well as a lot of healthcare is going to revolve around treating those infections with antibiotics. So, of course, we're going to see a lot of resistance develop in these areas, those collection points. We are also going to have a lot of people in those points where we have compromised host. So we have individuals that already have a compromised immune system going to these areas, and trying to get health care, right? Makes sense. This is going to lead to those opportunistic infections. So remember that an opportunistic infection is going to occur in an individual who is already immune compromised, and then that secondary infection is going to arise. And then we have this term chain of transmission. So there's going to be a lot of direct contact with sick people and indirect contact with those inanimate objects, those fomites or vehicles, due to improper handling or sterilization. So these are 3 reasons why it is more likely that healthcare workers will pick up and then transfer pathogens and carry them from patient to patient. So again, these are healthcare associated infections that we are now talking about, or nosocomial infections. Now, with that information, that we are perfectly aware that it is more likely to get an infection, in fact, a pretty gnarly infection, from a healthcare area like a hospital or a doctor's office, there are plenty of practices in place in order to try to prevent a healthcare associated infection, which, of course, going into this field, you guys are going to learn all kinds of ways to prevent an infection from traveling from patient to patient. Now, despite these practices being in place, roughly 5% of all admitted patients will still experience one of these infections. So someone will go in with one problem, and 5% of those individuals will come out with a new problem, which is kind of unfortunate, but if you think about it, those odds aren't all that terrible. So what are the most common infections that we see as a nosocomial infection? Well, here they are, but I only want you to remember 2 of them, and they may actually surprise you. Pneumonia and surgical site infections. Now, if you're already in the healthcare field, UTIs might feel like that should be higher on the list. It's not, shockingly, I know, but do know pneumonia and surgical site infections are the 2 most common nosocomial infections when it comes to that. Okay. Now, from this slide, the title is maybe a little bit of a misnomer here. These are going to be the 5 most problematic healthcare associated infections. And I would maybe rephrase this title here if you could. I didn't want to change it because I think your notes still have it as this, and I didn't want it to be too confusing. Please note that these 5 infections are real problems, real big issues when it comes to healthcare associated infections. I do want you to know each one. So C. diff, we've talked about it a few times. This is a GI infection. We have Staph aureus. This can cause pneumonia, as well as we can get it from surgical site infections and bloodstream infections. So make sure you know that. Klebsiella, certain species, so surgical site infections, urinary tract infections, pneumonia, E. coli, GI infections, surgical site infections, bloodstream infections, and Enterococcus species, so surgical site infections, urinary tract infections, and bloodstream infections. Make sure that you know all five and that these are all problem children when it comes to the nosocomial infections, those healthcare associated infections. So how do we control a nosocomial infection? Well, there's oodles of ways, and honestly, most of them, when you look at this list, are pretty much just common sense. Um, Now, I don't want you to memorize this list. These are all things that are going to become very much so second nature for you as you move into the healthcare field. But just know that this is going to be a list of ways of policies and procedures that will become incredibly commonplace for you, common sense for you as you move into that healthcare field. Ways to combat those nosocomial infections. So, how do we know that what we're doing in the healthcare field, in the world in general, is actually making a difference? Well, that's where the study of diseases is going to come in. So, we have these two terms, etiology and epidemiology. So, etiology is going to be the study of the cause of an infection and disease, where epidemiology is the study of the frequency and distribution of the disease, as well as other health-related factors in a defined population. Both are going to be the primary idea behind various public health organizations, like the CDC and the World Health Organization. Both are very important. So etiology is going to kind of stem as far as a baseline off of Koch's postulates. So as a gentle reminder of what those postulates are, it's this idea of taking a microbe that's present in every case where we see a particular disease defined by particular symptoms. That microbe must be isolated and grown in a culture. Then that disease must be reproduced when a pure culture is introduced to a healthy host. And then microbes must be recovered from that newly infected host. However, this is a great baseline. It's this very perfect world ideology that this particular microbe causes this particular disease. Except that's a lot easier said than done, because we know that there are polymicrobial infections where there are two microbes or two infections happening simultaneously. So while Koch's postulates are a fantastic baseline, it's not really as feasible as doing that. So it's again a good baseline. However, it's a lot easier said than done to do because there's not always just one microbe within an infection. Usually there are several microbes causing an infection, or sometimes signs and symptoms are a little bit more fuzzy and we can't perfectly define what the entire list of symptoms are for a particular disease. Now that leads us to epidemiology. Remember that this is that study of frequency and distribution of a disease. And when we look at the frequency and distribution, we have to take into account things like people who are infected, their age, their sex, personal habits, occupations, all kinds of things. There is so much data that needs to be gathered in order to look for patterns within that distribution and frequency, in order to determine anything about a disease, those factors that define the disease itself. In looking at all of that data, who's going to do it? The answer is various organizations like the CDC, as well as the World Health Organization. And the thing that I want you to know about these organizations is one, their name, and two, where they are based out of. The CDC is going to be based out of the US, and their primary mission is to promote health and quality of life by preventing and controlling disease, injury, and disability within the US, while the World Health Organization, or WHO, is based out of a global or worldwide agency, and their mission is the attainment by all people of the highest possible level of health. So both of these organizations serve the purpose of epidemiology, so studying the frequency and distribution of diseases in order to better help the world with different diseases, and especially new diseases that pop up, like COVID or SARS when that popped up. A little bit of history about an important woman with epidemiology is Florence Nightingale. She was a nurse during the Crimean War around the 1850s in what used to be Constantinople. She was a pretty cool lady. Who took meticulous, and I mean really crazy meticulous notes on just about everything, from if they changed the sheets from patient to patient to treating the dressings before putting it on an individual, or if they didn't treat the dressing and all they could do was just move it from one person to another, and they were, bloody dressings essentially, to if the latrines were overflowing that particular day. She also took notes on whether or not the patient's health was improving or not, if the patient died. But through her notes, she was able to see patterns of essentially cleanliness and the health of her patients. So she noticed a fabulous correlation between cleanliness and health of patients. And so she was one of the first epidemiologists, really, to notice that the frequency and distribution of disease perfectly related to the cleanliness and sterilization of equipment and materials that were being used. So, very important lady, Florence Nightingale. All right, so statistics in epidemiology. So this is going to come down to the frequency of cases. And we have two terms here. So the prevalence or morbidity rate, this is going to be how many total people currently have this disease. And of that number, we have incidence rate. This is going to be how many of those cases are new cases. Now, I know it looks like there's like some math on this page. Don't worry about this for just now. We're going to talk about this a little bit more when it comes to lab, but not when it comes to lecture. So don't worry about this for the exam. We are going to talk about this more when it comes to our disease report, but this is not going to be on the exam as far as being able to do the math. Just know those definitions for those terms. Next up, of course, is the mortality rate. This is the number of how many people have died from that particular disease, and of that, we need to identify what is a notifiable disease. These are diseases that physicians or health practitioners are required by law to report to public health services, such as to the CDC or the World Health Organization. So an example of a notifiable disease is Ebola. So if someone is diagnosed as having Ebola, whether they have died from it or they just have it, health practitioners are required by law to report that to the CDC or to WHO, because that is something that is highly contagious, as well as there's not a whole lot of things we can do to treat that particular disease. When COVID started, That was something that we needed to do, and it was a notifiable disease. It is not anymore. But when it started out, it was quite a bit of a concern that people report that they did have COVID. However, most people were not doing that. But now there's a handful of notifiable diseases. But again, health practitioners, physicians, nurses, etc., they are the ones that are required by law to report that to public health services. All right, so we need to talk about these patterns of disease within a population. There are 4 terms we need to know: endemic, epidemic, pandemic, sorry, I know that's probably triggering, and sporadic. These terms refer to a disease within a population. What does that look like? So endemic is a disease that is always around. A good example, the common cold. It is always around in some capacity. People are always getting sick with the common cold, but it's not really something that really concerns us all that much. An epidemic is going to be a sudden spike of that particular disease in a certain area. A good example was when Typhoid Mary was getting people sick with not washing her hands and cooking for those families in that particular area. A pandemic, one that we should all be unfortunately familiar with in common days, common times, is a worldwide epidemic. So a sudden spike in diseases, except it is a global event, right? So that is a pandemic. Good example, COVID. Sporadic is going to be this occasional case at irregular intervals at random locales. Good example, if a random restaurant suddenly has some food poisoning. So potentially that might happen. Now, to finish us out for chapter 11, we're going to talk about types of epidemics. Because there are types of epidemics, but this is the only one that we need to go a little bit deeper into. So we have point source epidemics. This is where a bunch of people get sick all at once. So think of like a restaurant that has a particular special, maybe it's like a special on, I don't know, a chicken frittata or something like that, or I don't know, some type of salad, who cares? But essentially everybody who orders that particular food, if it is widely produced and widely consumed, all of those patrons are going to get sick all at once, but we can pinpoint the source of being that chicken frittata or that salad or whatever at that particular restaurant, all at the same time, right? The common source epidemic is going to be something like a water source, maybe a well gets contaminated by maybe a dead animal is floating around in the well. I don't know, kind of gross to think about, but don't think too hard. But something gets into the water source and causes an infection essentially from that common source, right? If you can see where we're going with this. Now, it may take a little while before authorities or whoever get to the results, essentially, of what is causing that particular sickness. But eventually, we'll get to that main point that it is the water source, that common source, causing this sudden spike of illnesses. And sometimes it could be persistent or intermittent, because sometimes people go to that water source, or maybe they might go to a different water source. It just kind of depends. And then we have a propagated epidemic. This is going to result from an infectious agent that is communicable from person to person and is sustained over time in a population. But again, it's a sudden spike within a population that kind of persist. So that is it for chapter 11. Thanks for sticking through. I know it's a lot. This is a very dense chapter, but honestly, all the material in it is pretty kind of interesting, pretty fun. It is our interactions with pathogens and microbes in general, which is really quite interesting. So if you have any questions, please don't hesitate to ask. Reach out in any capacity. I'm here for you. Happy studying. Best of luck. Make good choices. And again, just let me know if you have any questions or need any clarifications.